Hey, it's Leaf here. So I wanted to reveal how I am fabricating and welding in the Corvette floor-mounted gas pedal for this LS swap in a 68912. As you can see, I used two pieces of 1-inch angle iron. One that was, they're both about 3.5, 4 inches long. One that was faced backwards with the upper lip in the back, because if you look at the OEM gas pedal, it goes like this. So the bolts, which I'm exploiting right here, that go through the floor pan and through that piece of metal in the bottom that's kind of a pedal cluster mount, is used such that the two bolts are in front and then the rubber gas pedal's in the back. And I measured the angle on this, and I just tack welded this so you can see, based on the angle, that it's very close. It worked out to be about 22 degrees from the floor. So you need that angle because you have to stay away from the brake pedal. If you mount these Corvette floor-mounted gas pedals just flat on the floor at this plastic seam here, so this is down more, and this angle would come up, and then the gas pedal would be too close to the brake pedal. So I put three small tacks in this. I used a vice grips to lock down both of those pieces of angle iron, and then put a tack way on the inside here that you can't see, and then one here, and then one there. Now I will unbolt these bolts and then take the bolts here, the two bolts holding the gas pedal to this mount, to the bench, and then weld them. There is a third mount hole that you can see, which is back here, that I need to, that I will run a piece of flat stock coming from the tunnel here, and I'll weld that on the tunnel and then come over and then behind the upper mount on the gas pedal. So there you have it. It's not too complex of a job, but just a way, an idea to fabricate the mount for this. I also have, I'm more than 6 feet tall, so my feet are a little bit long. These Corvette pedals are quite short. That's only approximately about 8 to 9 inches long. So you can see the length, pedal to pedal, you can see the length of the Corvette pedal starting at the bottom. If you hold it equal to the Corvette mount here, you can see how high the OEM Porsche pedal is. So it is longer. So it's not going to bother me by having this up a little bit. The other trick that's kind of important is that, I'm trying to move over here a little bit closer, that you got to, I raised it up here because you need some clearance between, the pin is here, the 6 pins plugs in right here, it comes in from here where my index finger is, so the 6-pin connector is here, and then you need to keep this connector assembly housing, this plastic housing, away from the tunnel. So if I want to get, I have noise reduction rubber here, Dynomat over this, and then some carpeting. So there's about 3/8 of an inch here. So you need to keep that clear. And that's one of the advantages of raising this pedal up in this fashion here, such that the lowest point in the corner is probably about 1.5 inches from the floor pan. So we are now at the metal fabrication bench, basically my workbench, and I'm showing you a close-up of the construction of this E-pedal mount. This is the floor-mounted Corvette pedal from 2014, and the structure of the iron angle is such that you have these two holes that are approximately about 40 millimeters apart. I drilled 5/8 inch here. You could use a quarter, but I went a little bit larger. Now those two holes are used for the bolts that go through the floor pan. They are offset because of the angle of my pedal cluster. Being so old, nothing is always square. So, and I actually welded in, you can see in another video, I welded in some floor pan steel to fix a rust spot where water came in the master cylinder slot. Here are the 3 tacks that I put in when this was in the car. So on the side, if you look top down for the plan form, you can see that it looks like this. So there are your 2 pieces of angle iron. And out now on the top, where the E-pedal bolts into the into this mount, that cadmium colored brass looking bolt is a 1/4 20 by about 1 inch. And then on this side, you can see these 2 holes here. They measure out for the distance in the E-pedal here. On this side, it was very difficult to try to, I took this all apart. I took the pin connector off, this assembly off, and then we use undoing these 3 star screws, and then I took this off, and there's some small plastic mechanism in there for which I tried to disassemble it so that I could slide this piece of plastic here out of this, coming this way up out of the pedal, and then this is just a piece of plastic that acts like a hinge, has a hinge function on the bottom, which should slide out this way towards the camera, but I couldn't disassemble. I didn't want to break anything, so I just left it. And then I really learned, I knew from the beginning I wanted to drive a nut. I want to take this off so I could put a nut on the top. But all you need to do is just come up from the bottom. So that's a 1/4 with a flat, and then a 1/4 with a flat and a lock and a 1/4 inch bolt on the nut on the top. Now the other thing that I noticed was that using on this top piece, this 1 inch piece of angle iron that's here on the top, you need a little bit extension welded onto that, because you can see that the mount of the E-pedal goes past 1 inch, so I needed a little bit more meat there on the steel. You can see that you're still supporting the plastic structure if you go out about another 1/2 inch or to 5/8 of an inch. So I welded on, I cut off a piece of angle iron flat and welded that flat on here. Ground off the bead here a little bit near where these washers are and here, but left these in the bottom because you're not going to see those. But I ground the welds on the top flat. I also beveled each side off. So it was a butt weld with 245s on the top and bottom of each edge. So I just ran a straight bead down those, just a single pass. And that is about it. Now what I'm going to do on the bench is weld. I only tacked it, so you have to be careful of warping with steel. So I won't weld here anymore. I could, in the car, I can only get here, here, and here in the front. So warping, naturally, when you weld, if you weld, wherever you weld, it's going to cool this way. So this could likely be bent. I'll have to, it looks like it didn't warp, although I'll have to put it on a flat and see. So what I'll do, all this is by way of saying that what I'll do first on the bench is weld on this back side, so that when it cools, it will bring this up. Because cooling welds towards beads. So I'll put 3 hits here, and flip this, run maybe an inch bead here, flip it, run an inch bead here, right here, flip it, run an inch bead on this edge here, just about an inch. It's only 1/8 inch thick steel, so you don't want it too hot. And then I'll run about an inch bead here. Finally, finish off in the middle here with right here with about 1.5 inch bead. I'll need to grind these down right now though, because your spot welds should be grinded. And then I'll finally finish one long, another about 1.5 inches here on the back. And as you can see, you know fundamentally that whenever you weld 2 pieces of steel together, this is low carbon steel, you have to grind off the mill scale. You can see this gray colored mill scale here, which prevents rust and is coated on the steel at the steel mill at the time of manufacturing. And then you need to grind off with a die grinder about 1/4 of an inch on the edge wherever you're going to run a bead. And then also you can see in that total bottom piece, I didn't know where the angle would work out, so I just cleaned off all the mill scale there. And then on the back you can see there's about 1/4 of an inch there's a 1/4 inch cleaned off here. You can see it right here. This is cleaned off, and then this is all cleaned off here. So that's all very cleaned up. Hey, Leif here. I'm showing you the results of welding on the shop bench for the E-pedal mount in the Porsche. So they're not really spectacular beads, but it was a little bit hard to get back in there because I couldn't really get at a good 10 to 15 degree angle directly into that seam right there. So also the one continuous bead idea was broken up because you have to flip-flop this from side to side. I'm now showing you the other side. As I said, you have to flip-flop this piece from side to side and tack here, probably about 1 inch long. Flip it, tack on the other side about 1 inch long on the reverse side over here. Flip it, tack on this side, flip the piece, tack, seal up the other side here. And then finally, when you're done, just run about your 2 inch or 1.5 inch long through in the middle here. But there wasn't really a lot of space here because this lip was facing up, so you couldn't really get in here at a good angle. At your 10 to 15 degrees going right in. So it was MIG welded, 339 inches per minute. The wire diameter is 0.030, so 30 thousandths of an inch. And I'm running about 20 cubic feet per minute of 75% argon and 25% CO2. The voltage works out to be a little bit north of 17.5. I'm running in DC electrode positive as well, which is commonly a default setting in all MIG welding. This wasn't stick welded, it was welded with MIG, so shielded gas. Didn't use flux core. I have a flux core welder, which I've used before, which is not too bad, but I used MIG here because I can weld in the shop. Flux core happens to be really good on a farm or something if you want to just take a power cord or a generator on a truck and sling something on your arm to what appears like MIG welding. You're using the same stick, the trigger gun for the wire, but MIG is a little bit better, but you do need to transport the bottle of CO2 or C25 gas, 75% argon, 25% CO2. So that's it. There you have it. The results of bench welding this 1 inch, these two pieces of angle iron together after they were brushed off and cleaned.